Differential equations. Differential equations are equations that contain derivatives. So examples would be y double prime plus x y prime equals 0. And so there are many different notations for these derivatives to write it as. There's the Leibniz notation, which is known like this, dy over dx, or d squared y over dx squared, etc. And if we convert this into prime notation, this would be y prime, and this one would be y double prime, and we can just keep going like this, etc. And there's two other notations, which are the Newton's dot notation and subscript notation, but those are used for physical sciences and engineering, so we won't be talking about them in this video. Now let's continue on to orders. Orders are the highest derivative found in the function. And so for example, in this function, the order would be 2 due to the 2 lines here, or the second derivative. If you have a different function, for example, y triple prime plus 3xy double prime plus y equals sine of x, what the order for this one would be 3 due to the third derivative here, which is the highest derivative. And we can also write a first order differential equation, which is like y prime plus y equals 0, in a different notation, which is m of x comma y dx plus n of x comma y dy equals 0. And a thing to notice, m of x comma y is basically a notation for a single function. So an example of this would be y minus x dx plus 4x dy equals 0. And in normal form, we can also write first order differential equations, and that is dy over dx equals f of x comma y. And if you were to do this in second derivative, this would be d squared y over dx squared, which is equal to f of x comma y prime, and so on and so forth. If we were to have to an nth derivative, it would be d to the nth y over dx to the nth, or I'll just write that down, d to the nth y over dx to the nth equals f of x comma y prime comma etc. and so forth to y to the nth minus 1 derivative. And so now let's talk about linearity now that we have orders in place. And linearity is basically when the derivatives of the function decrease by 1 or decrease in order. So an example, if we were to notate that, there would be a sub n of x to the d to the n of y over dx to the n plus a sub n minus 1 of x d to the n minus 1 of y and over dx to the n minus 1, and we would keep continuing this and adding them all the way down to a sub 1 of x dy over dx plus a sub 0 of x y equals some function g of x. So examples of this would be y minus x dx plus 4x dy equals 0. And another example would be y double prime minus 2y prime plus y equals 0. Now, and as a third example, d cubed y over dx cubed plus x dy over dx minus 5y equals e to the x. Now we should notice that the derivatives keep decreasing in all of these examples. However, in the last one, the derivative skips over the second derivative, which is completely fine. It doesn't have to go in order as long as it decreases. And we should also notice that the coefficients are functions of the independent variable. In this one, y minus x is the function of x, and 4x is also a function of x. And this is again a function of x, and this is another function of x with the derivative of y. And y has to always be a power of 1. It cannot be a power of 2 or 3 like y squared or y cubed. And as opposed to these linear functions, these are linear, we have the nonlinear ones. So obviously nonlinear is any function that's nonlinear. So examples for nonlinear functions would be 1 minus y prime plus 2y equals e to the x, or d squared y over dx squared plus sine of y equals 0, or d to the fourth of y over dx to the fourth plus y squared equals 0. Now each of these has a different problem with them. If we look closer at this one, we can see that the derivatives are decreasing by 1, but the coefficient is not a function of x or the independent variable. It's a function of the dependent variable, y. So this is wrong. Let me make that red. Wrong. And now, what's the problem with this one? Well, if you look here, sine of y, that is a function, that's a nonlinear function. So obviously the whole differential equation becomes nonlinear. And here, it's a power of 2, not 1. Like I stated earlier, the dependent variable must always be a power of 1. And in this case, it is 2. So this is a nonlinear function. And this is your basic introduction to differential equations.